So this video is on Integrated 3, the Chapter 10, D-Day number 4. So on this, it says write out the series, but I'm not going to make you write it out. I'm going to ask you to compute, to solve for the sum. So they want us to sum the 16th term up to the 93rd term. So we have to be careful because that is not 93 terms. It's going to be 93 minus 16. And then you're going to add one on. And when we do, we're going to end up with 78 terms. Okay, so 93 minus 16 plus 1 is 78. So we have 78 terms. You also need to recognize that this is arithmetic. So since this is arithmetic, we're going to be using the following formula. S sub n is equal to n times the quantity. This makes it a little bigger. A1 plus a sub n all over 2. Now in this case, we found that the n was 78. Now, I don't want A1, I actually need A sub 16, and I need A sub 78, the first and last term that they want me to add. So I am going to, into this equation, substitute in 16 to see what I get. So I'm going to have 84 minus 13 times 16 is, so 84, 843 minus 13. So hold on, helps if I actually write the right equation here, huh? So 843 minus 13 times 16, which ends up giving us 635. Now I'm going to substitute in 78 into that same equation. So let me just change this to a 78. And I get a negative 171. So I'm going to substitute that into this equation. So I'm going to have S sub 78 is equal to 78 times 635 plus a negative 171 divided by 2. And that's going to be the sum that I need to compute. So 78 times the quantity, 635 minus 171 divided by 2. So I end up with 18,096 for the answer. Now the next problem is geometric, and for this one, when we want a geometric sum, we're going to be figuring out a1 times 1 minus r to the n all over 1 minus r. Now in this case, I am starting with my first term through my fifth term, so my n is going to be 5. I need to find my a sub 1. So to find a sub 1, I'm going to substitute 1 in there. So I'm going to go 7 times 4 to the 1 minus 2. So 7 times 4 raised to the 1 minus 2, or basically negative 1. Oops. Now if I'm doing this on Desmos and I want 1 minus 2, in the exponent, I need to go parenthesis 1 minus 2. So I just have to be careful if I'm typing it in. So that's going to be 1.75 or 7/4. So this is going to equal 1.75. Now my r is what we're timesing by. That's the thing that's raised to the power. So that's your 4. So we're going to find S sub 5 is equal to 1.75 times 1 minus 4 to the power 5, close your parenthesis, all over 1 minus 4. Okay. So when I work that out, 1.75 times the quantity, 1 minus 4, raised to the power 5, and then divided by the quantity 1 minus 4. And I end up getting 596.75 is our sum. So on number 3, they want us to write it in summation form. We need to figure out what we're doing. And when I'm looking at this, I start off with a decimal. So let me see. Let me take 113.8 and subtract 97. And I see that that's a 16.8. Let's see if that's the same as 130.6 minus 113.8. So yeah, I'm adding 16.8. So this is arithmetic. And what we need to do first is we need to figure out our a sub n. So a sub n is a sub 1 plus d times n minus 1 for an arithmetic one. And so a sub n is going to be 97, and we're adding 16.8 to the times n minus 1. And so I've used my summation notation. I'm going to start from 1 to infinity. Infinity because they didn't give us an end. So that's why this is to infinity. And then my a sub n is 97 plus 16.8 times the quantity n minus 1. And that's your answer. On number 4, this one is a geometric one. Sorry, it's moving. This one is a geometric one, I believe. So I'm going to take 98, which is the second number, and divide it by the first number. And I get this awful decimal. I'm going to hit this fraction and see that that's a 1/7. So now let me see. If I take 98 times 1/7, okay, I get 14. So it works out. So I need to find a sub n for this geometric, and that's going to be your first term times r to the n minus 1. So our a sub n is going to be 686 times, and we are timesing it by 1/7 to the n minus 1. And so I'm going to have summation notation n equal 1 again to infinity because they have dot, dot, dot. And our equation that we're using to generate this is 686 times 1/7 to the n minus 1. And that's your answer. On number 5. So on this one, we want to sum the first 22 terms. Looking at this, looks like I'm subtracting 7 each time. So this is going to be arithmetic. And so for the arithmetic sum, I need n, how many terms we're adding, my first term, my last term, all divided by 2. So n is going to be 22. A1 I see as 84. Now my a sub 22 I need to work out. So I'm going to do a sub n is equal to 84 minus 7 times n minus 1. So I'm going to be plugging 22 into this. And so when I plug 22 in, I'm going to have 84 minus 7 times 21 when I do that math. So 84 minus 7 times 21. I end up with a negative 63. Okay, so that's going to be my a sub 22. So now I'm going to do s sub 22 is equal to 22 times my first term, which is 84, plus my last term, which is a negative 63, divided by 2. So that's going to end up basically being 11 times 84 minus 63, which is going to be a 231. Okay, on number 6. This one looks to me like this is geometric. So for this, let me figure out by taking the second number, 1,792, divided by the first, which is 7,168, and I get 0.25. Now, let me just take 1792 times 0.25, or 1/5. And yeah, it works out. I get 448. So this one is going to be S sub n, because it's geometric, A1 times 1 minus r to the n all over 1 minus r. My n is 8. My a sub 1 is 7,168. My r is what I'm timesing by, which is 0.25. So I'm going to find S sub 8 is equal to 7,168 times 1 minus 0.25 to the power 8 all over 1 minus 0.25. So I'm going to have 7,168 times 1 minus 0.25 raised to the power 8. And then my denominator, 1 minus 0.25. And so I end up getting 9,557.1875. Now, on the next question, they ask us for the infinite sum. You only can do the infinite sum for geometric. And the formula is A1 over 1 minus R, but there's a restriction. This is only if your R in absolute value is between 0 and 1. And in this case, our R is, because it's a 0.25. So that is within this range. So I'm going to do S is equal to 7,168 over 1 minus 0.25. So when I do that math, I basically have 7,168 divided by 0.75 if I do that math in my head. So I'm going to end up with 9,557.3 repeating as our answer. You see that's close to this. So you see that as it gets bigger and bigger and bigger, it's going to start going closer and closer to 9,557.3 repeating. Okay. So on the next page, on number 7, find the sum. So looking at this, since I end up with this decimal here, I'm thinking this is probably geometric. So let's see, let me take 24 divided by 16 and I get 1.5. And let me take 24 times 1.5 and I do get 36. Okay, so if I want to figure out how many terms this is, and this is geometric, I take my first term. Well, here, let me again just write the formula. It's going to be my first term times r to the n minus 1. So r a sub n is going to be 16 times 1.5, because that's our r, raised to the n minus 1. And I'm going to put this number in for my a sub n. So 273.375 is equal to 16 times 1.5 to the n minus 1. Okay, I am going to divide both sides by 16. So when I do that, I end up with, let me just make sure, did I copy that right? Okay. And that's what it would be as a fraction, but let me just write this. So 17.0859375. I'm not going to round it because I want to get a nice answer, and I'm worried if I round it, I will not. So now I'm trying to solve for my exponent. So when that happens, I need to use logarithms. So I'm going to take log base 1.5 of 17.0859375. And that's going to be n minus 1. Let me see if we have logs here. We do, but it's not the log I want. Let's see if I can actually. Let's see if it'll let me type it in. It may not. Let me try. So log base, I did shift 1.5 of 17.0859375. And I guess it won't let me. So I can do this by doing change of base, but let me just get a Desmos calculator up with graphing calculator. So I am going to come here to functions, and I think it's at the bottom. Okay, here, log. So I'm going to do log base 1.5 of 17.0859375. And I end up getting a nice answer. I end up getting 7. So 7 is equal to n minus 1. So when I add 1, this is going to be the 8th term. Okay, so now they want us to find the sum. Remember, this is geometric. So I'm going to be using a1 times 1 minus r to the n all over 1 minus r. And so I want to find s sub 8. And so my first term is 16. 1 minus, and we are multiplying by 1.5 to the power 8 divided by 1 minus 1.5. Okay. So let me just get back to this calculator. So I'm going to divide 16 times 1 minus 1.5 raised to the power 8 over 1 minus 1.5. And I end up getting 788.125 as our sum. Okay, on number 8. So this one, I have decimals right away, but looking at this, I do think it's arithmetic. So let me take 842.6 and subtract the first term, which is 861. So I get a negative 18.4. So I'm minusing 18.4. So let's see, 842.6 minus 18.4. I did end up getting this. Okay, so it is arithmetic. So for an arithmetic one, I'm going to have a sub n is equal to a1 plus some d times n minus 1. So in this case, we're going to have a sub n is equal to 861, and we are minusing 18.4 times n minus 1. So I'm going to stick 401 in for a sub n. So 401 is equal to 861 minus 18.4 times n minus 1. So I am going to take 401 and subtract 861 from both sides. So I'm going to get a negative 460 is equal to negative 18.4 times n minus 1. So I am now going to divide a negative 460 by a negative 18.4. 18.6. 18, not 0.6, sorry. 18.4. Okay, that gives me a nice answer. So I get 25 is equal to n minus 1. So n is going to be 26. So this is 26 terms. So now to find the sum for an arithmetic one, S sub n is equal to n times my first term plus my last term all over 2. So I am going to be doing S sub 26 is equal to 26 times my first term, which is 861, plus my last term, which is 401, all over 2. And I end up with 26 times the quantity, 861 plus 401, divided by 2. And I ended up with 16,406. Okay, on number 9. We want to find a sub n for this geometric. So again, a sub n is equal to a1 times r to the n minus 1. If you're starting with your first term. I'm not going to start with my first term. I'm going to start with my third. So my a sub n is going to start with 176 times r. Don't know what r is yet. And instead of it being raised to the n minus 1, it's going to be n minus 3 because it's my third term. Then I'm going to use this and substitute this. So I'm going to put that in for my a sub n. So 45,056 is equal to 176 times r to the 7 minus 3. So 45,056 is equal to 176 times r to the 4th. And I'm going to divide both sides. So 45056, I'm going to divide it by 176. And I get 256 is equal to r to the 4th. I'm going to take the 4th root of 256. And when I take any even root, I always get a positive and a negative answer. And so when I take the 4th root of 4th root of 256, I get 4. So I get a positive and a negative 4. Now, if this was an exponential equation, like for a graph, I would only use the positive. So my integrated ones are only using the positive. But for us, since this is a sequence, it could be positive or negative. So 1 a sub n is going to be 176 plus 4 times n minus, sorry, not plus, we are timesing, times by 4 to the n minus 3. Another one is going to be a sub n is equal to 176 times negative 4 to the n minus 3. Both of these are equations. On 10, similar idea, but this is arithmetic. So again, we're doing a sub n is equal to a1 plus d times n minus 1. And again, we're not starting with the first term. I'm starting with my 7th. So I'm going to start with a sub n is equal to 363 plus d times n minus 7 because it's my 7th term. And I'm going to put this in to my equation. So 1522 is equal to 363 plus d, and that's my 25th term. So I'm going to go 25 minus 7. So 1,522 is equal to 363, and then that's going to end up being 18d. So I'm going to divide 1,522 by 363. 363, 7th term. Just double checking my math real quick. Oh, well, I wasn't supposed to subtract, divide. I was supposed to subtract. So let's start again. it was 1,522 and I was minusing 363. And so I get 1,159 when I minus is equal to 18D. Now I'm going to divide 1159 divided by 18. And I end up getting, let's see. $1,522 minus 363 equals 1159. 1159 divided by 18, just double checking math. So I'm not seeing any issue with the math here. So I guess we're going to end up getting either a decimal or a fraction for this. So again, I put that in 363 plus D and N minus 7 because it's my 7th term. I put this in 1522. It's equal to 363 plus D, and then it's 25 minus 7, which is 18. I subtracted 363 from both sides, and I got 1159. And then we're going to divide by 18. So it's going to be 1159 divided by 18. That is my D. I'm going to keep it that way, or you can think of it as 64.38, where the 8 is repeating. Okay, either one of those. Now they want an equation. It's going to be kind of an ugly equation, but it's going to be a sub n is equal to 363. Let's say I do the decimal, so plus 64.38 repeating times n minus 7, because that's our 7th term. On number 11, so I'm going to expand this. So I need to do Pascal's triangle. So I'm going to do 1, 1, 1, 1, 2, 1. I need to get to the row that's a 1 and then a 5. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. That's the row I'm going to use because of this 5 here. So I'm going to start with 1. Makes it a little smaller. Okay. I'm going to start with 1 times x. And here, let me make this bigger so I can make this a little bigger for you to see. X to the 5th. And now I'm going to be dealing with my 5. So plus 5 times x, and now that's going to be to the power of 4. And my 3y is going to be to the power of 1. These have to add to this 5. Okay. Each time those are going to add. And then I have a 10. So this is going to be plus 10 times x to the 3rd and 3y to the 2nd, because 3 plus 2 is 5. And then 10 plus a 10 times x to the 2nd, and that means my 3y is going to be to the 3rd. Plus 5 times x to the 1st and 3y to the 4th. And last, I'm going to have 1 times 3y to the 5th. So for my first one, I'm going to have x to the 5th plus, for this next one, when I'm doing it, I have a 5 times a 3 to the 1st, which is just a 3. So 5 times 3 is going to give me 15 x to the 4th y. Plus, now this is going to be a 10. There's no number here, so 10 times a 1. So 10, and then times 3 squared, which is 9. So that's going to give me a 90 x to the 3rd, y to the 2nd. And then my next one, I have a 10, and then I have a 3 to the 3rd, which is a 27. So this is going to be a 27 times 10, which is 270 x to the 2nd, y to the 3rd. And then I have plus, and I have a 3 to the 4th, which is 81. Let me just get my calculator here. Okay, so I have a 3 to the 4th, which is 81, times the 5, so it's going to be 405, x, y to the 4th. And then I'm going to have a 3 to the 5th, and 3 to the 5th is going to be 243. Okay, so it's going to be 243y to the 5th. Okay, so my answer, x to the 5th plus 15x to the 4th y plus 90x to the 3rd y to the 2nd plus 27x squared y to the 3rd plus 405xy to the 4th plus 243y to the 5th. That's our answer. And on number 12. So this is going to be a binomial probability. And for this, we want to find the probability that when you roll a dice 8 times, okay, so we're going to have trials of 8, you get a 3 exactly 5 times. So we're one probability of a 3. So probability of 3 when we're rolling a die is 1/6. Probability of not a 3 is 5/6. And we're rolling 8 times, and we want to get exactly 5 times. We want to get 3 5 times. So it's going to be 8 choose 5. And so I'm going to get my 1/6, which is the probability of a 3 to the 5th power, and my 5/6, which is the probability of not a 3 to the 3rd power, because those are going to have to add to the 8. Okay, because if they have 8 trials and 5 of them aren't, then 3 of them are. Okay, and then I'm going to put this into my calculator. And when I do that, I'm going to take 8 choose 5 times 1/6 to the 5th. Whoops. Let me start again. Let me restart. Okay. So it's going to be 8 choose 5 times 1/6 raised to the, whoops, want it raised to the 5th. And let me expand it out. And 5/6, so I can see when I'm typing. 5/6 raised to the power 3, because these have to add up to the 8. And I get 0.00417, let's say. So I get 0.00417 as our answer. And that's the end of this video. Hopefully that will help you out on these problems, and the test is going to look exactly like this. So study, study, study.